All right, let's dive into something that's probably protecting you right this second, even if you don't really think about it. We're talking about one of the most fundamental pieces of cybersecurity, the firewall.
I mean, really think about that. Every single time you go online, you're connecting to this vast, wild, and sometimes chaotic digital universe. So what is that first line of defense? What's standing guard, keeping all the bad stuff out?
And yeah, the answer is a firewall. But if you're picturing just a simple brick wall, you're not giving it nearly enough credit. It's way smarter than that. Think of it more like an intelligent, evolving guard, a bouncer for your data that's always learning new tricks. Okay, so let's really break this down. What is the firewall's core mission? What's its whole reason for being? At its absolute core, a firewall is a filter. Simple as that. Its entire job is to sit between two different network areas and basically decide which data packets get a VIP pass and which ones get stopped at the door. And to do its job, a firewall has to see the world in pretty black and white terms. It divides everything into zones. On one side, you've got your trusted zone. That's your cozy home or office network. And on the other side, you've got the untrusted zone, the Wild West of the open internet.
And this brings us to what I like to call the firewall's golden rule. By default, it's pretty chill about traffic that starts on your side and heads out. But any traffic trying to come in from that untrusted internet, oh, that's a different story. It's incredibly suspicious of everything, and the rule is, if it's not explicitly on the guest list, it's not getting in, period.
So okay, how does our digital bouncer actually decide who gets in and who gets kicked to the curb? Well, it all starts with a very specific and very powerful rulebook.
This most basic level of security is called packet filtering. The firewall is basically like a postman glancing at the outside of an envelope. It doesn't read the letter inside, but it checks the to address, the from address, and what kind of mail it is, then checks its rulebook to see if it's allowed.
And this right here, this is a perfect example of what that rulebook actually looks like. It's just a list of rules. The key thing to understand is that the firewall reads this list from the very top down to the bottom. The second it finds a rule that matches the packet it's looking at, it follows that rule and just stops reading.
And that top-to-bottom processing is absolutely critical. The order of your rules means everything. If you put a big, general deny all rule at the top, none of your specific permit rules below it will ever even be seen. That's why you always put your most specific rules right at the top of the list.
But, just checking an ID at the door isn't always enough. What if the bouncer could actually remember the conversations happening inside? What if it had a memory?
Well, that's exactly what the next big evolution in firewalls does. It's called stateful inspection. Instead of looking at every single packet like it's a total stranger, the firewall now keeps a little logbook, a state table, of all the ongoing conversations.
And having that memory, it's a total game changer. Think about it. When you ask to go to a website, the stateful firewall makes a note. So when that website sends data back to you, the firewall checks its notes and says, "Oh, right, I remember you. You're the answer he was waiting for. Come on in." It can open a temporary, secure door just for that reply.
All right, now we're going to get into one of the absolute cleverest tricks a firewall can pull off. This wasn't just a security feature, it was a solution to a massive, looming problem for the entire internet.
See, here was the problem. The internet was growing so fast, way faster than anyone ever predicted, and we were literally running out of unique public IP addresses. Every single device couldn't have its own. We needed a fix, and we needed it fast.
And the brilliant, ingenious solution was something called Network Address Translation, or NAT for short. NAT lets a whole building full of computers, each with its own private internal address, share one single public address when they talk to the outside world.
So how does it work? Just think of the firewall as a super efficient receptionist at a big office building. Your computer sends a letter out. The receptionist, firewall, makes a note of who sent it, puts the building's main address on the envelope instead of your desk number, and mails it. When a reply comes back to the main address, the receptionist checks their logbook and delivers it right back to your desk. Brilliant.
Okay, now you're going to see some official-sounding terms for this stuff, but don't get hung up on memorizing them. Just focus on the idea. The inside local address is just your computer's private address before the swap. The inside global is the public address it wears when it goes out into the world. It's just a way to label where the address is in its journey.
So we've covered the basics, filtering traffic and swapping addresses, but modern firewalls do so much more. They've really become the central security hub for an entire network.
For instance, a firewall can act as a proxy, which is kind of like sending someone else to the store for you. It hides your real identity. It can also do content filtering, blocking certain websites during work hours. And it can even demand authentication, making you prove who you are with a password before you can get anywhere. This is where next-generation firewalls really shine, because they can look inside the data to understand the actual application, not just the address.
Okay, here's a really cool and super important concept in network design, the DMZ, or demilitarized zone. The best way to think about it is like a secure lobby for your network. It's a special, less trusted area where you put all your public-facing stuff, like your company's website.
And why does this matter so much? It's all about separation, containment. If a hacker manages to break into your public web server, they're trapped in the lobby. The firewall won't let them get past the DMZ and into your actual trusted network, where all the really important stuff, the crown jewels, is kept safe.
So when you step back and look at the whole picture, it's pretty amazing, right? We started with a simple wall, a basic filter, and we've ended up with this smart, stateful gatekeeper with a perfect memory that can swap identities on the fly. It is, without a doubt, your network's most essential guardian.
But here's the thing. This evolution is nowhere near finished. The threats out there are getting more and more sophisticated every single day, often using AI to launch attacks. So that leaves us with one big question. What's the next step? How will our digital guards have to evolve to keep up?